Thank you very much, Helvig. I'm really honored to be here and happy to be here to talk to this seminar. And it's also the first time in long that I'm talking here in this department and I'm very happy to be here and get some 45 minutes of attention from a lot of great people that I can feel that were out there. Thank you very much for coming. And also thank you to those who are online. And I assume somebody couldn't come because days are busy. So as Helvig said, I'm working here, mainly in Bergen. I still work at Chalmers, which is the sister city of Bergen, also on the west coast of Sweden. So I'm using Widerøe airplanes sometimes. Okay, so here is the chronological order where I studied. Actually, not totally true, because I did study in Trondheim applied mathematics with a lot of great people there. Some of them actually work here in Bergen now. And I did my last year on the School of Applied Mathematics in Grenoble, which is one of the two places for applied mathematics in France. It's Toulouse and Grenoble. I did my master's here in two-phase flow fluid mechanics. And then I switched gear. I went through industry experience, and then I did my PhD in human-computer interaction, which was not really a topic back then around 1997. So I was actually looking at the horizon, looking for the topic, and I could do my PhD in that topic, which was really amazing to get in so early in the area of human-computer interaction. And I worked here at Chalmers and also in Bergen since 2018. I also had a great chance to work as a teacher at the University of Zurich, an assistant professor at Singapore, Tohoku, and also again ETH. So that's one way to see the chronological path, the scientific path. I also tried to map my experience on countries by their ICT, say, maturity. So I see that I've worked in many different countries with various level of maturity in terms of ICT, which I think is an interesting thought. It's just a reflection. I'm not trying to make any country look good or bad here. I've also worked quite in sensitive Eastern countries, Poland and Turkey, where there's a lot of great people. So it's just to say that the ICT maturity of a country does not mean that you cannot do good research in or with those countries. It's not that easy. It's not black white. I just want to say that. But to start back, you still have it on your retina, the stationary research. So I start with some project coming out of stationary computing. So as I said, I've been quite much into touch input, also collaborative systems. And here we see a project which was funded by Celtic. It's a Eureka mechanism, which is funding collaboration typically between two countries and a few companies. So this was with Ericsson plus some smaller tech companies back in Sweden. And also in Switzerland, actually, it was a joint project. So what we studied was how can brainstorming be supported efficiently for teams that are partly in a hub, but also partly with a remote, a satellite brainstormer. And this is, of course, a topic that became more, say, accentuated in the last few years, and I think it's not going away. How can we support teams that are distributed? That's the big topic. And how can we work creatively and effectively over distance with people who are in different places? And that's, of course, will be a reoccurring, I call it a persistent problem in my language. So we went from this established metaplan method, which is a good method, it's used by a lot of industry, and studied how can various forms of multi-touch devices be incorporated. And we came up with some technique, for instance, timeline or clustering of ideas and so on. And there's a lot of documentation on this. So for those of you who are interested, I can point you to more details. But I'm moving on. So this was one of the chapters in a PhD of Yuri, just finished recently. He went to ABB. Now he's a professor in Vietnam Technical University. And another step of his PhD, which I like quite well, was that he explored how can we use inexpensive devices and combine them with existing devices we have around us. So in this case, he took a regular tablet, and it was a little bit before the I don't know, when did the 360 cameras come out on the market, the one you place on the table picking up the room. In any case, he took this little piece of plastic which picks up the scene. So the little camera and the piece of plastic picks up the scene, and there's a Kinect picking up the moderator. So the whole idea is here, how can you get the remote brainstorming incorporated into the process using really existing or inexpensive technology? And you see there's some computer vision and segmentation going on here naturally to make that work. So let's have a look now what this actually looks like. Okay. you see the 360 here is actually not there because the video, but now you can see it. So that's the mobile device and mobile app. An interesting thing is that the mobile brainstormer can actually get a good view of what's going on around the table, but also here another bar and the replica of the brainstorming canvas. It's a longer video, but I prefer to move on. So, I mean, ideas are necessary, they're good, and ideas need to be structured in the way we live in our culture and also in most part of the world. However, it's also appealing to work with physical props. For instance, if many people learn mechanical engineering, or chemistry, or say architecture. And if you are working with physical components or props, you also want to learn how to assemble them, and maybe you want to do that remotely. So it's not only about remote or distributed brainstorming, it's also about distributed assembling, understanding spatial relations, gaining spatial skills, and actually pointing, showing to parts of the problem and passing on knowledge. So in this work, in this one of these chapters, he studied also an inexpensive technology. It's quite an interesting one. He mounted a mirror here. So the mirror partly picks up the hand, so the system picks up the gesture, and part of the camera here picks up the facial expression. So on the other hand, you can actually get both on this side, and it's also used as an overlay. So you can see the physical scene here, and you can see the gestures, you can see the facial expression, and everything up in the structure. So it's I would say, low-cost augmented reality without head-mounted display. Of course, these things can be done with HMD as well. I'm not going there in my presentation today. Before later on, I'm showing some examples of 2017. So as you have noted, there was no evaluation in these. Actually, in this study, it was quite an exhaustive evaluation, but I'm not presenting it. But when I'm coming to the next examples of my or our research, I should say, because it's definitely not only me. I also want to show some of the evaluations. So here is some of the work I was doing while I worked in 2016, 2017 in Tohoku University. It's a university located a bit north of Tokyo. It's actually where the tsunami hit. So when I came there, you could still feel that it was in reconstruction, and it's an interesting atmosphere. So I was happy to work. I mean, the master students there really do a great job. So I work with Hagiwara-san, who was a master's thesis student in computer science, and also with Udo-san, who's also a master's thesis student. And it was quite a nice situation because my only job was to supervise one master's student, but to do that well. I really liked the situation, and then to do all the other stuff I was doing, of course. Actually, in this project, I have to say honestly, when the student came in and talked about the idea, I thought it was a bit strange, and but I learned about kind of the Japanese way of thinking, of coming up with ideas that can be quite wild, but it actually can land quite well. So this project, Camcutter, is actually about application mirroring or application sharing. And you probably heard and read about that. It's about how can you take an application from one device to another one. And there are many ways to do that. I mean, and in this case, we studied vision-based application sharing, meaning you take your camera, you photo what's going on over there on the big screen, and you get a thin client jumping to your device. That's, of course, very meaningful. You can do that for paperwork. If, let's say, your colleague printed a Word text and it still sits in Word, you overfill it and you get the word jumping to your device. Or you can do it for maybe for presentation, so that two students can actually pick down different parts of the presentation, see them more in depth, maybe interact with them, and so on. So application sharing has quite some potential, and I think vision-based application sharing, given the amount of use of cameras that we see, which is rather unintelligent. I mean, we take photos of Ulriken or of Sandviken or Statum Lemkull, and it's beautiful, of course. However, it doesn't really allow us to interact with what we're seeing there. So there are two stages of this. I mean, stage one is take a photo. Stage two is take a photo of something which is fixed and that connects you, and that had been known before. And the third stage is to take a photo of something dynamic and also crop it and take out part of the image, which is something we studied here. So I'm going to show a video of that. So this is going a little bit towards the in-motion interaction, because you can move around in the corners. So typically we got critique when we took 2.5 years to publish, probably because I think some company are looking into these techniques too, honestly speaking. So one reviewer was very resistant, and that review popped up 3 times before we published it. So that was very interesting, and it indicated that some companies had photos showing that type of way. Apple's using one camera to film that another one, but it's not out on the market yet. It's been in the newspaper. Okay, so in-motion interaction, stage one. In-motion interaction, stage two was, and that connects to a problem I've been working on myself, namely tabletops. So tabletops came out around 1996-7, and I was developing some of the early ones, meaning interacting desktop, and I developed those multi-touch back then. Well, 1997, 3 years before the phones became multi-touch. So, but if you have a large tabletop, you will get an issue of reach. Reach means I'm standing or sitting here and I can reach over there, but I cannot reach over there. And that will stay. That's also, I would call that a persistent problem. I mean, the way humans are laid out will stay much the way it is now. You're not going to change. I think the problem with reach will be there also in 1,000 years, given that we have tables. And tables have been around for 2 or more 1,000 years. So it's actually an interesting problem. I mean, it's a classical problem. How can, with our human body, how can we reach part of a larger table, and particularly if that table is an interactive one, we want to reach. Now, we are used to vertical screens, and then we can walk up and down, stretch a little bit. So the problem is a little bit less acute, but for horizontal large screen, it's definitely a problem, which maybe has been holding back this kind of tabletop technology a little bit, but that's a speculation. So let's have a look at the video.
Camcutter, impromptu vision-based cross-device application sharing. Working and sharing data over different devices has become a challenge thanks to the increasing number of both devices and applications being used at the same time.
Doesn't really want to. Yeah, maybe. Let's have a look. It's on there. It is. Oh, you know what I did? I turned down the sound on this very video, so I'll start again. It was when we discussed here before, so that will work. There we are. Problem known. Okay. And then we come back to the Camcutter.
Camcutter, impromptu vision-based cross-device application sharing. Working and sharing data over different devices has become a challenge thanks to the increasing number of both devices and applications being used at the same time, making it necessary to switch between them. To address such challenges, we developed Camcutter that enables the camera of one device to quickly connect to an application window on another device, which allows for impromptu cross-device application sharing. Camcutter is based on recent advances in computer vision for feature detection and consists of system architecture, software implementation, and interaction techniques. System architecture.
It's going a bit too wild, so I jump.
Here we see a diagram of the
That's the end of the system architecture.
client-server
really
architecture.
Wider, so it's not a contribution, but maybe
To connect with the shared application on any of the host devices, the camera of a client device is used to take a picture of an application window and sends it to the host devices. Based on the image sent, each host device uses an application window detection algorithm to make scores of its windows and returns the calculated scores to the client device. The client device then selects the window with the highest score and establishes a connection with the selected host device. We now briefly go over some interactions using Camcutter. Capture application, touch interaction, drag interaction, and terminate application.
User study. Reading task.
I'm not going to show that either. I'm going to give you a PowerPoint with all the videos, and then you can go and look for those who want. But we compared it to Google Docs and to TeamViewer, and it outperformed TeamViewer pretty well. And Google Docs also part of my right memory. Thank you. Now, clearly, TeamViewer has other features. I mean, it's used industrial. I'm not saying it's a bad software. That's not what I'm saying. But for this kind of use, it was an interesting comparison.
Camcutter, impromptu vision.
Okay, and now I'm jumping to the other project, which I did over there. Let's see. I think I go to 145 here. Yeah. It's the movement tables.
Adaptable, extending reach in large tabletops through flexible multi-display configuration. During the flexible situation, participants could change the table layout.
We call this some low-cost prototyping. I mean, it was tables without any more.
Here we see the three most preferred table layouts,
just by positioning
above for
that.
reaching,
So
below for docking.
no movement.
From this study, we found 4 screen layouts, merged, slide, single slide, and split, to be preferred by users to minimize physical demand and frustration levels. Prototyping and screen control study. The adaptable system consists of 4 touchscreens, each equipped with a Roomba robot for display sliding. An infrared motion capture system was used both in the screen control study and later on in the comparative evaluation. Secondly, we explored alternative ways of controlling the multi-display layout to design adaptable. We examined a touch menu, touch gesture, and user position. The touch menu was clearly preferred. Comparative evaluation. Finally, we conducted a study comparing adaptable with a conventional panning technique. The tasks studied were a flag task and a number task. Both required reaching and docking and gave significant results. For 2 scenarios, left, vertical, and large, adaptable showed lower task completion time than panning. For the number task, adaptable showed lower frustration levels than panning. In 4 of the 5 scenarios, adaptable is preferred over panning.
So what's going on here? So we tried in Chalmers to rebuild the tables, and we did with some success with robots. And we wanted, of course, to make an advance. So luckily, you saw the preferred layouts in the beginning. Luckily, I have to say, where configurations you can do with robots that either move on the X or Y. But I mean, it could just have well been that the user had preferred tables of different tilt angles, and that didn't happen. So that was lucky. And we checked that with agreement analysis to make sure that we just didn't pick the layouts that work for those robots that go X, Y. So now we are working with some robots that can go on curves. That's not so easy. We found out practicalities. When you test them on linoleum, you should test them on carpet so that they have better difference. I mean, there's a lot of regulation here and there, which is definitely beyond my knowledge domain. And we did get some funding in the Polish National Academy. So we're working with the student there now to rebuild the robots and to see if we can get it going with robots that not only move on curves so that they can give better configuration, but also using some USB tracking systems so that, for instance, if the user is moving, the table will follow the user and stuff like that. So we have quite some elaborate ideas on how to extend this. Okay. That was
adaptable.
And here, I mean, of course, this can be combined. I mean, the Camcutter and adaptable can be combined, but that's really a bit further in the future. So, okay, moving on. I was also lucky to work with some good people in from China, or in whatever you call China, Hong Kong. Canning Xu is based in Hong Kong, and I worked a lot with him, and both in Sweden and Hong Kong. And he has done some work in his past on foldable user interface, which you can now see industrial on the Samsung, of course, and stuff. I mean, the mobiles that fold and I don't know, flip and fold. So that's on the industrial side. So a few years before those things emerged, we studied the problem, which is how can you actually interact with smartwatches, given that their screen real estate is really small. So, okay. You know that on the smartwatch, I don't have one, but you know that they have good operating systems. So you can actually do your overleaf documents with 200 pages on a smartwatch. But I don't know if anybody's doing that. I mean, first, it's quite draining your vision. And second, there's a lot of clutching going on the screen. So it's not really suitable. So, of course, I don't think we're going to have big screens on the wrist. I don't think that's a solution. But maybe if you double or triple or quadruple the space that we have on the wrist, maybe that could be a solution. And probably to get there ×5, this is not the way to go. Or I don't know, does anybody of you, I've seen people wearing two watches who live in 2 time zones, probably on the east and west coast in the US, they have that. But I mean, it's still not a solution because your visual field is just too scattered. So you want to have your screens on the same wrist, and you want to have more screen real estate. So how does this go? Okay, so first we speculated around some applications, like saying, why does this research need to be done at all? So we came up with some application, at least indicating or motivating why such work would be worth pursuing. You can see things like telecommunication, Skype, whatever, weather forecasts, city plan, architectural plans, mapping. We even came up with a mini cube there, like the walk-in VR experience, maybe seen from the outside. And due to great skills of Canning, we were able to also prototype this. And he lives close to Shenzhen, where there's a lot of ability to actually get the material, get the, for instance, the there was one interesting challenge here. It was, these are hinged and they're also elastic, so you can pull them. So it means that you can use not only position control, which is the base control we use in HCI, but also rate control, meaning pulling things. It's what you have on your CAD mouse when you're tilting your little knob there, that's rate control. So we could have that on this device. So let's have a look what that looks like. And I think there's a minute count here too. Let's see. So as you can hear, I'm from Bergen, and in Bergen there's a lack of listeners. People speak fast and a lot. So do I speak too fast for you, or it's okay? Fine, thank you. I'll try to pronounce clearly and hope it's okay. Let's see. Again, I skipped the intro stuff. That's too much. Even though it's nice, but it's too much.
The design of wrist origami's structure was strongly inspired by origami. There are 4 displays surrounding the central display, each display adopting the dimension of an Apple Watch. The side displays are connected by rotary hinges and rubber strings, allowing them to be folded. We also use the hinge mechanism in the middle of the side display panel to support flipping. The elastic string-based connection between each side display and the center of the watch further supports pulling interactions. We conducted 20 user-elicited design sessions to investigate possible user motivations and perceptions for wrist origami applications. Lastly, we show a list of application demos based on the exploratory study. We believe wrist origami will open up new possibilities in smartwatch design.
Now, some of the work I've been lucky to do, again, with great students, and this is when I worked more for a long period in Singapore with those colleagues. We studied in the Kai paper, so it's been quite excited. It's the motivation for eyes-screen interaction. So back then, 2011, we were in the middle of mobile interaction, so it was in the era of having a mobile phone at all. That was the big thing. What can be the motivation for not looking down in your screen all the time? There's plenty of motivations, and here we systematically studied a few of them, or maybe, hopefully, all of them. But now we're 10 years later, so I think this in motion aspect actually can be added to these motifs. I'm also like sometimes to acknowledge that other people also do great work. This is Karen McLean. Yes, I'm smiling too. Of course, it's obvious. I mean, Karen McLean is a leading figure on wearable tactile haptic interaction, and I've read her work. It's very stimulating. I mean, she has studied which domains of use. Why is it so helpful to have haptic, both output and input? I mean, actuators and sensor on the body. So she's a great star in this field. I've been happy to do some smaller piece of work. This was with Jason Aldina, who was at NUS also back then, and with Simon Perron and Sloman, I think he's somewhere in Europe now, I'm not sure. We studied the quite interesting challenge if you not only have one haptic bus on your mobile phone, which we all have. I guess some mobile devices have two. Is that true? Did any of you take it apart? I guess some of them have two, but I don't know. But if you place them strategically on the mobile phone and then stitch it to your body, well, in this study we found out first, we are good at picking up the orientation, better or worse depending on where on the body we place it. We are not that good to say that it's A, B followed by F, but we are quite good to say that, to recognize a certain pattern, even though the pattern is rotated or stretched. So it's actually possible to use haptics on mobile phone for certain alphabets, but not for what you would think of kind of as first step approach, but the second step approach, yes. So I'm just showing some little snippets of that work. Yeah, there you see the positions we tested. And this is a short video, so we can show the whole thing.
Inform about a much larger variety of events. We can use multiple vibration motors to create spatial temporal biprotectile patterns. However, people tend to touch their phones at different body sites depending on context. For a notification system to be effective and perceived, it needs to be reliably recognized across these common body sites. People seem to be able to reliably tell whether two sequential vibrations happened at the same location or not. This inspired us to come up with a set of patterns solely based on these four considerations.
Okay, break is also never wrong. We have 10 minutes left, so I'll move a bit more quickly. This is a little piece of work, and it actually, I'm going to show you. So what I showed you, just to put some system into the craziness, what we showed before was how to make use of haptic buses on mobile phones. A related problem is, while we are walking and let's say we're running or biking, how can we say, I want accepting from a phone call, or I want to copy my document into the mail and send it to my friends for review and pick it up 1 hour later, and you're on the bike, you're running. So how can we control? What are the buttons when we don't have a screen and we don't have a touch screen? So that's what we did, studied in this move space work. And I'm just going to show a little bit of the work. It's quite fancy in the sense that it took place on some very fancy setting and there's nice music. That doesn't mean that the science is good. In self-reflection and after looking back, I'm not sure, but we can see. So you see a set of locations that have an effect on running form, and that's good for input came out. And similarly for biking then, other results came out. I guess such information can be interesting to have for, say, where from the bikes. Where would they put the sensors on the body? What would they support? So it's going towards guidelines, design guidelines here, I would say. A nice photo. It's all published, whatever. I have a version of the PowerPoint with all the publications. It's not only Kai, but mostly Kai. So here's a project a little bit along the same direction, supporting colorblind users. So in this room, there's probably 3 males and 1 female who are colorblind, going by statistics, and there are different types of colorblindness. And that can be quite bothersome if you want to shop clothes or if you want to go for the right vegetables or fruits. So the motivation is quite clear. Now, in this work, we did not study computer vision, and we did not study any tweaking glasses or anything like that. We studied how can you bring over the colors picked up by the camera to a wristband, and how do you do that with haptics. So we studied how many haptic buzzes do you need, and what sequence and what intensity and all that. That's what we did here in this paper. Again, it was a great master thesis by Marta. She went to Singapore. She did half of the work in Sweden and then the other half over there. She was very busy, and I think this was so intensive that she went on. I haven't seen her since, but she did a great work. I have to see. I know that work. So we studied accuracy with different. That's the accuracy with a different number of buses. So 3 or 4 motors is a good thing, and of course 3. This is a bit chunky. You see the experimental setup.
Color blindness affects a person's ability to perceive colors and can contribute to difficulties in everyday life and at work.
Okay, so now we leave the real world, or maybe we go into the real world. So I didn't say a single word about virtual reality, and I know that, like Ilona, we have much more leading experts about VR in the room than my expertise. However, as you know, VR is a growing domain, and it will surely grow if there is no major setback for other reasons. But growing on its own base, it's growing. So these are just some general comments about VR. So within VR, there are some also what I would call persistent problems. I mean, when we're indoors, we have limited space. This room is 10 by 10 meters. But if you have a VR gaze or maze or a VR scene that's maybe 20 or 100 meters by 100 meters, how would you solve that problem? So some of you have probably heard about redirected walking. That means you give the user cues so that the user walk on different arches and lines. And these are below the perceptual threshold. So the user will not perceive that he's walking that way. He thinks you walk straight. So you can actually elude a space that's much bigger than the physical space. So this is really supportive for escape games or other kind of games. And again, with the colleagues in Togo, we did some work with redirected walking, not a classical one, we give a visual cues, but actually we give haptic cues, because the haptics will also consume some of your attention and also, redirect your attention in a way. So in a way, I would say this can be part of my vision. And in this work, we studied redirection by turning doors. So you come into a room, you walk around, and then you add a thrust, like you reduce the turning angle, and you add it a little bit, and thereby you can get a little redirection. So this can be used actually for to gain space or to extend the space of the VR application. It's the same here. This got an honorable award on IEEE VR, and it will be shown at SIGGRAPH in a short time. Saying time is slow is short. This and that. Let's see, what more comments do I have? I saw this little image when I presented these things first on my way to the presentation, and I thought that Poland had picked up my ideas even before they're out. But it's a street badge there in Łódź. That was quite sweet when I saw that. Yeah, I have some more reflections, but I think time is out. So now it's question time. Thank you.
Thank you, Morten. You have really prepared a lot of information about fascinating projects. Thank you. At various places. Very, very fascinating. And I'm sure that there are questions to you. I just wanted to mention if anyone online had a question, I will try and pick it up from the chat. So if there is a question online, you can post it into the chat and I'll try to see. But before we take care of our online audience, maybe I have a look into the room and whether there are questions. So please, yes.
Morten, can you please tell us something about your experiences with
Yes. Mhm. Yeah. I think, I mean, a few quite successful evaluation was this adaptable. There we really pushed it far to evaluate it well, and also the camcorder, simply because there was more time. These were masterpieces that could be pushed really far. And also in the multi-device interaction, which I've been working on for many years, we've done exhaustive evaluation. So if you look at the paper, you will always find, not always, but mostly find a lot of evaluations or a significant amount of evaluation. However, I mean, I would say that many of these projects are there to prototype and to investigate ideas. So I mean, it's an evaluation makes sense with many of these works, and but not always. I mean,
then you are choosing those evaluations.
Definitely. I mean, how I choose them. Okay, it's mainly what you call ABBA studies, like classical usability studies. It's not something super fancy. I do not say that I contributed so much to empirical evaluation methods. I did contribute a little bit, but in my PhD to the theoretical foundation of this field and activity theory, but that's a long time ago that it's not worth talking about.
Can I just add a question to this question, because
Sure.
it's interesting, I think. I mean, empirical tests clearly is one choice of evaluation that should be maybe thought of first. But you have also a lot of experience working together with industry, and in a way, I also accept this as a form of evaluation. It's maybe not scientific, but you know, if it sells successfully, think of it as a form of positive evaluation. Would you say?
Definitely. Like in a brainstorming project, which was already to get an Eureka or Celtic project funded, it needs to be industrially relevant, and we had such a few ones. You've seen them. And secondly, we had some industry like companies doing these kind of collaborative boards. And so, some of those companies have put that into their palette of products. So I mean, and I knew the question would come. I have some slides, and unfortunately, it was so busy as that I couldn't add the slides. But I have proof that. Let me see if I can find that. Afterwards, we will take a 1 minute break. I will dig up some proof of industrial relevance. I prefer that we move on with the question, but there is a lot of industrial relevance, and I think it can also count for validation, but not only, of course, because it's
Stefan.
Yeah, maybe connected to this. I was wondering. I mean, and you said you're testing out ideas and concepts. And I was wondering, in your experience, really, how strong is the influence of the actual technical realization versus the concept? And what I mean by that, for instance, you know, 15 years before the iPhone, Apple tried out with the new like touch interfaces and stylus input and so on. The technology was not quite there, and it was not really successful. And it took another 15 years till the technology was there to really make this work. Or I don't know, maybe 10 years ago, more than 10 years ago, we had the Wii, and everyone was saying, yeah, motion controllers, this is great, this is going to be the future, and it went away again because it was not just precise enough to do real things. So what do you think is the threshold there? Or how do you know whether the concept is bad or just the technical instantiation of the concept?
Well, that's a good question. Thank you. I mean, already in tech areas, many companies get funded, and they get heavily funded, and still it doesn't mean that they get success. So I think there are many stages in this technology readiness level, which is the measure for where you are. And I mean, I have some paradoxes here which I could show. In universities, I mean, I've heard the critique that's too high TRL, that the research I do is too high technology readiness level. And but others might say, and your question indicates, is the technology readiness high enough? I mean, or what can we learn about that? Or am I right? Or
And even more so, if we are just in the prototyping stage,
yeah,
is it possible, is it feasible, can we even detect whether it's a bad concept or we are just not good enough to realize the concept?
okay, that's a good question, and that's a deeper knowledge of all this, and that's the underlying knowledge. So I would say, and that's why I put up my research agenda. We need to study more how does hand-eye coordination function for humans. It's not, I think, and I've done some time to dig into it, we do not fully understand how hand-eye coordination actually works, working with computers. So there is a need for better models. And I can tell you, for instance, the work of Christian Holtz, who is now at ETH, only several years after the touch phone multi-touch phone came out, he had a paper at WIST showing that the model of where we think we touch and where the phone thinks that we touch is skewed. So simply by compensating that offset, you can get a much more precise touch input. So our understanding of how we work with technology might also have to improve. And so there are many layers here. Understanding human, understanding our interaction with basic sensors is needed. And then we will also understand why a technology can succeed or flop. So I think there are many layers here. Now, in university, we typically train students. So these projects are there to train students to the best of their potential. Yes, that's another driving factor here. It's partly PhD works and partly master thesis. So the level or the depth of understanding is variable, I would say. And the level of TRL is variable, and there are compromises all the time. So yeah.
So
in this domain.
Recognize that there are more questions.
I hope.
Fit in one from the online audience.
Sure.
May I just read it to you, Morten? So Shireen says first, thanks for the nice talk and thanks for showing the videos. Do you also include efforts to consider factors like trust, safety, and well-being related to aspects and connections with new mobile interaction research activities?
I can say absolutely yes. So I talked about the proposal. That proposal was, that's rejected, so it didn't go anyway. I don't know why, but I do consider that, yeah, well-being, how interaction actually supports our well-being and working with computers, and trust as well. Yes, trust a little bit less, but well-being more. Yeah.
I had one question that kind of follows up in
Yeah.
a way, and that is, you see, I am sometimes scared when I'm biking and I see someone in front of me with looking on their mobile. Yeah,
Clearly,
because of safety questions. So, do you think that some of these new ideas they can actually make it safer? This mobile interaction?
Yes, I definitely think so, and I have an answer to that also. And let me see if my other PowerPoints comes up now. It's media refinement. Yeah, there we are. So no, it's the wrong presentation, but it shows the idea. I mean, I had one student, Alex Dankou, who worked with mid-air display and also pervasive display. So, I mean, it's true that if we have our phone here, we are kind of locked to that. But if you can display things mid-air, which is 50 years away, because plasma technology is not fitted into our mobile phones yet, and it will take another 50 years. They're big boxes, so holographic display are really far away. This in ours is probably far away. But the same student also proposed pervasive display, meaning you could, for instance, while you're on your bike, project the map on the street and interact with it while it's on the street. So it's in the same field of vision as where you're biking. And this has also been proposed by Nissan around 5 years ago. They haven't pushed it, but I think some car producer actually also, in parallel to bike production or bike design, work on displaying information where we are looking anyhow. Now, this can work perfectly well in North, because we have go to work, leave work when it's dark much of the year. So it will actually be very supportive. If it's too sunny, it's a problem. So yeah, that's
a problem. When it's
that's not a problem. This was great work. It was actually quite fun work. We used some Pico projectors and we tested how this supports the mountains and stuff like that. So yeah, it was also the bike project doing the same thing.
But I think there were more questions. Maybe, yeah, Thomas.
Hello,
You're welcome.
I'm more asking for guidance. I'm coming from visualization, and sometimes should I include an existing technology, or should I rather research a new concept that doesn't even exist? I think that translates to your research in the way that you can research how I know that's going to match this place.
Yeah.
But you can also research how you interact with the hologram, where initially it's not a problem in this place. But
Yeah.
how do you then decide whether you choose to?
I can be quite honest. I worked with a PhD for 3 to 4, preferably for 5 years. So my approach is to find out what that person brings and where the potential in that person is, and then to bring that person to her or his max potential at graduation. That's a very good strategy, and there is enough to take from in terms of ideas and research challenges. So I see the cake as really unbounded in terms when it comes to research challenges and technology. The limiting factor is good students. So that's the substance I work with mostly, and then to combine it all. So I do not, I mean, okay, when I wrote this proposal of emotion interaction, it's my ideas, and it's my kind of idea child, but that's not all the time. I mean, it's partly I work on my own ideas, partly with the substance of intellectual potential embodied in human beings.
So I think we can take at least one more question. I think Laura, one.
This was a really inspiring talk. Thank you.
Oh, welcome.
I had a question for you about accessibility. So it's not my major research, but I recently had to dig into like people who have motor disabilities.
Yeah.
You mentioned a little bit of the visual disability thing. But I'm wondering how this sort of mobile interaction that we're talking about with this stuff that's a little bit more maybe future looking. Can you speak a bit how you think that can work with people who have Parkinson's or something like
that? That was a critique point when we developed the concept that not everyone can walk. So I totally agree that's a challenge. So it could be that I come up with a concept that doesn't work for everyone. However, so designing or researching interactive solutions, it's partly about meeting the needs of those who have special needs and partly of those who large population, but it's a totally valid question, and it's not happy to make everyone happy at one time. Yeah, you could say the same for traveling to the moon. It was not accessible to people in wheelchairs, but it was still necessary to do. For developing Teslas, the first Teslas were probably not supporting wheelchair users. Maybe they don't do it yet, but I mean, it's still some things have to come before other things, I would say. So it's a matter of priority. Yeah, but it's still a good question. Thank you. The colorblind project is supporting accessibility issues. People who have colorblind issues, probably also who are blind. I suppose that such haptic notification can help blind users, but that's pure speculation, really. And the same for the movement tables can, of course, also support people who have accessibility issues. In the concept, they could also go up and down and reconfigure and meet the user's needs where they are. So some of this is maybe accessibility friendly, but not all of it. Yeah.
So in the interest of time, maybe, I mean, usually I consider lots of questions as an indication that the talk was very interesting.
Thank you.
Inspiring. So in that regard, I think we are in a good position to thank you, Morten, once again for your contribution and your talk. Thank you very much.